Good morning, students, and welcome back to another video lesson from the chapter Atoms and Molecules. As you can see right now on your screen, we'll be discussing a very important topic from this lesson, the mole concept. But today, the first part of this lesson will be dedicated to some introductory topics, and in the second part, actually, we'll be getting into the mole concept. So, let's begin with today's topics. The first one being molecular mass. We have studied in our previous lessons that the mass of the atoms of an element is known as its atomic mass. It is in fact the relative mass and is expressed in unified mass units, that is U. In the same way, the mass of the molecules of a chemical compound is termed as the molecular mass. It is also the relative mass compared to 1/12 of the mass of carbon atom taken as 1U. Thus, molecular mass of a compound may be defined as the average mass of its molecule as compared to the 1/12 of the mass of carbon taken as 1U. Now, this topic will become much more clear once we carry out certain calculations. The molecular mass of a substance can be calculated as the sum of the atomic masses of all the atoms which constitute a molecule of the substance. So we can take an example for molecular mass of ammonia having the formula NH3. So that should be equal to the atomic mass of nitrogen plus 3 times the atomic mass of hydrogen. Why should we take 3 times the atomic mass of hydrogen? Because there are 3 atoms of hydrogen. So as we all know, atomic mass of nitrogen is 14 units, and for hydrogen it should be 1 unit. So this taken together gives us the molecular mass of ammonia as 17 units. Let's consider 2 more examples. Let us consider first of all the example of a simple compound, water. We all know formula of water is H2O. So molecular mass of H2O should be equal to 2 times atomic mass of hydrogen plus atomic mass of oxygen. So that is equal to 2 into 1 units plus 1 into 16 units. So that is equal to 18 units. Similarly, let us take the example of sulfur dioxide, that is SO2. So similar process, molecular mass of SO2 should be equal to 1 times the atomic mass of sulfur plus 2 times atomic mass of oxygen. So atomic mass of sulfur is 32 and twice atomic mass of oxygen 16. So 32 plus 32, that gives us 64 units. So in this manner we can find out the molecular mass of many compounds. Percentage composition of a compound. Percentage composition of a compound is the relative mass of each constituent element in 100 parts of its mass. Now let us find out the percentage composition of sulfuric acid. We know the formula of sulfuric acid is H2SO4. For this, first of all, we have to find out its molecular mass. So that should be equal to 2 times the atomic mass of hydrogen plus 1 times the atomic mass of sulfur plus 4 times the atomic mass of oxygen. So this will be equal to 2 plus 32 plus 64 units, and that is equal to 98 units. So this is the molecular mass of H2SO4. So in order to find out the percentage of composition, first of all we have to find out the percentage of hydrogen. So that is equal to mass of hydrogen divided by molecular mass of H2SO4 multiplied by 100. So that is equal to mass of hydrogen was 2 divided by molecular mass is 98 into 100, and that turns out 2.05%. Proceeding further, for sulfur, that is equal to mass of sulfur divided by molecular mass of H2SO4 into 100. So that is equal to 32 divided by 98 into 100. So that comes out 32.65%. Last of all, let's find out the percentage of oxygen. So that should be equal to mass of oxygen divided by molecular mass of H2SO4 into 100. So that is equal to 64, because there were 4 atoms of oxygen. 64 units divided by the molecular mass, which is 98, into 100, and that comes out 65.30%. So in this manner we can find out the percentage composition of a compound. Gram molecular mass. The gram molecular mass of a substance may be defined as the molecular mass of the substance expressed in grams, which is numerically equal to the molecular mass in unified mass units. So we can take the same example. We just calculated the molecular mass of ammonia, which came out 17 units. Therefore, gram molecular mass, or what is also called the molar mass of ammonia, that will be equal to 17 grams. Let's take one example. Calculate the mass of 0.72 gram molecule of carbon dioxide. Let's find a solution to this question. We have to find the mass of 0.72 gram molecule of carbon dioxide, that is CO2. So for this, let's find out the molecular mass. So molecular mass of carbon dioxide, that is CO2, should be equal to 1 into atomic mass of carbon, that is 12, plus 2 into atomic mass of oxygen, that is 16. So that turns out to be 44 units. So gram molecular mass of CO2 will be equal to 44 grams, or we can write down 1 gram molecule of CO2 to be equal to 44 gram. Therefore 0.72 gram molecule of CO2 should be equal to 44 gram divided by 1 gram multiplied by 0.72 gram. So that comes out equal to 31.68 gram. So the mass of 0.72 gram molecule of carbon dioxide is 31.68 gram. So these were some of the introductory topics related to mole concept. In the next video lesson, that is the second part of this particular topic, we shall be discussing about the mole concept.